Okay, so this is how to balance chemical equations. Right, so chemical reactions are a chemical change in which one or more substances are converted into new substances. Right, so remember back at the beginning of the semester, we talked about physical changes and chemical changes. In physical change, a substance's appearance may change, but in a chemical change, you're actually producing new substances. Right, now, we represent chemical changes with chemical equations. Right, so in a chemical equation, we have reactants on the left-hand side and products on the right-hand side. Okay, so in this chemical equation or reaction, we have carbon dioxide and water are going to react to produce glucose and oxygen. All right, so these are our reactants, carbon dioxide and water, and our products are glucose and oxygen. All right, whenever we have a chemical reaction, the law of conservation of mass always governs that chemical reaction. And by this, what this refers to is that during a chemical reaction, matter is not created or destroyed, it's only transformed. Okay, so here's an example of it. We have a candle before it's burnt, and we're going to enclose it to capture the gases that are emitted once it's burning. Carbon dioxide is the product that's produced. Right? If you were to capture all the carbon dioxide that's produced, that's released, the smoke, and you were to capture it so that you could measure its mass and include what's left of the candle, the mass of the candle before it's burned will be equal to the mass of what's left of the candle plus the mass of the carbon dioxide that was released. So we're not getting new atoms. New atoms aren't being created. New matter is not being created. It's only being transformed into new substances. Okay, and this is easier to really explain when we're looking at the chemical reactions. So here we have carbon dioxide and water reacting to produce glucose and oxygen. So here are our new substances. But when we look at what they're made up of the individual atoms, we still have carbon, oxygen, and hydrogen atoms. And here we still have carbon, hydrogen, and oxygen atoms. Now what has changed is that our amount, when it's written out like this, there are more carbon atoms on the product side. There's 6 carbon atoms here, and there's 1 carbon atom here. There are 2 hydrogen atoms on the reactant side, 12 here, 3 oxygen atoms on the reactant side, and 8 on the product side. Okay, so this would mean that we would be creating 5 carbon atoms out of thin air during this chemical reaction, and that's not what takes place. So what we have to do in chemistry to know what reaction would actually take place is to balance reactions. Okay, so here we can see that there are 6 carbon dioxide molecules, or 6 carbon atoms, 12 hydrogen atoms, and 18 oxygen atoms on the reactant side. And when we look here over at the product side, there are 6 carbon, so they're equal, 12 hydrogen, and 18 oxygen. All right, and so how this came about to be equal, this reaction is what actually does take place. In order to produce glucose and oxygen, there must be 6 carbon dioxide molecules and 6 water molecules. Otherwise, the reaction won't take place because you won't be able to make that glucose. Okay, so that's why we have to have balanced reactions in chemistry. All right, I just talked about that. Okay, so what we do to balance reactions is we use what are called coefficients. Right, so we've talked about subscripts before, which are the little numbers behind an element, and that refers only to the element in front of it. We've talked about superscripts, where they were oxidation numbers, +1, +2, and they were up high. Well, coefficients are the same size numbers as the elements, and they apply to every element behind it within that one molecule. So this 6 doesn't apply over here, just applies to the carbon and oxygen. Okay, but what this is saying is that there are 6 carbon dioxide molecules here. Okay, so there's 6, right? 1, 2, 3, 4, 5, 6. So in other words, there are 6 carbon atoms. So we're going to multiply every element within that molecule by the 6. So there are a total of six carbon atoms, and there are 12 oxygen atoms. There's 2 here, 2, 4, 6, 8, 10, 12. Okay. All right. When in relation to the subscripts and these coefficients, you have to multiply them. So when we have this 6 carbon dioxide molecules, you just take the 6 times the 2, and that tells you that there's 12 oxygen atoms there. Okay, now remember that any chemical equation, any chemical, written for any chemical formula is a ratio of the atoms to each other. So even before the 6, ignore that 6, there's a 1-to-1 ratio. Yeah, there's 2 oxygen atoms for every carbon. Well, even after we add that 6 coefficient in there, it's still a 1-to-2 ratio, right? We just divide the 12 by 6. We still have 1 and 2. Okay, so we're not changing the ratio of the actual atoms within the molecule. We're only going to say we're only changing the number of molecules present. Oops. Okay. All right, so in balancing equations, there's 5 simple steps, and it's easier to show you than to read these to you. Okay, so the first, the reaction that we're going to work with here is propane and oxygen. And we need oxygen to burn propane. And when we burn propane, we end up with water and carbon dioxide as our product. Okay, well, this reaction itself can't take place because it's not balanced. Here we have 3 carbon atoms, and here we only have 1. Here we have 8 hydrogen atoms, and here we only have 2. Okay, and here we have 2 oxygen atoms, but we have 3 oxygen atoms on the product side. So we have to balance this before we could ever burn propane efficiently, or at all, actually. Okay, so when we balance equations, the first thing that you do is you list each separate element on the reactant and product side alphabetically. Okay, so C comes before H, which comes before O. So we've got CHO on the reactant side, CHO on the product side. Okay, so our second step, now we're going to list how much we have just to begin with of each element on our reactant side and our product side. Okay, so over here on the reactant side, we have 3 carbon, we have 8 hydrogen, and we have 2 oxygen. On our product side, we have 1 carbon, we have 2 hydrogen, and we have a total of 3 oxygen. We have 2 here and 1 here, so that equals to 3. All right, so our third step, we're going to start at the first element, which is carbon in this case, and we are going to find common numerators. We're going to make them equal. Okay, so since we have 3 here and 1 here, we know that we can multiply this side by 3 so that it would be 3, and 3 would be equal. Okay, so to do that, we put a coefficient up here in front of where the carbon is. So that's the coefficient. We're going to put a 3 up here. When we put the 3 here and multiply it, now we've got 3 and 3. Our carbons are equal. Okay, but that 3 didn't just affect that carbon, it also affected the oxygen. So our next step is we have to change whatever elements we affected by our coefficient, right? So we already have the 3, but now we've got to change the oxygen. So we've got 3 times 2 is 6. We still have that oxygen there, so we've got to add that 1 for a 7, a total of 7. Okay, so we're up to our fourth step. What we do next is we're going to move down to hydrogen and work at hydrogen. We have 8 and we have 2. Okay, so we know that 2 goes into 8 4 times. So we can put a coefficient of 4 up here for a total of 8 hydrogen, and then the hydrogens are equal. Carbons already equal, now our hydrogens are equal. Did this affect the oxygen? Yes, it's going to affect the oxygen. There's going to be 4 oxygen here, and then we had 6 here. So that's going to be a total of 10, right? 4 and 6 is 10. Okay, so our carbons balanced, our hydrogens balanced. We've got to work on this oxygen. So we've got 10 here and 2 here. So obviously 2 goes into 10 5 times. So we can put a coefficient of 5 up in front of that oxygen, right? So we've got 10 oxygen over here. 5 times 2 is 10, right? Our carbons are balanced, our hydrogens are balanced, and our oxygens are balanced. right? And we're done. So your last step when you think you're done is to check your work. And it should already be written down here. We know that if these are equal, your reactants and your products are equal, you know you've done it right. You know that's a balanced equation. Okay. Our next step, I'm going to come in over here. So concentrate over here in this little webcam thing. We're going to balance this. And I'm going to show you how easy it is to actually do this in person. All right, so we've got mercury oxide reacts to form mercury and oxygen. So the first step was to list our elements alphabetically. So we've got Hg and O. Okay, Hg and O. Okay, so sometimes this is confusing to students that these little subscripts. Some might think that's three different elements. Remember that every chemical symbol for every element always begins with a capital letter. So when you see the little subscript, that's not a new element. All right, so it's Hg and O. That's all we're dealing with. Okay, now our second step was to list how many. So we have one mercury here, one oxygen. Here we've got one mercury, and we've got two oxygens over here. Okay, so now I'm going to change pens to make this easier. So where our mercury is already balanced, so we're going to go skip down to the oxygen. We have two oxygen here and one oxygen here. So we know we can multiply this by 2, right? By a 2 to change it into 2 and 2. So in order to do that, we've got to put a 2 as a coefficient up top here. Okay, so that way. Okay. And now our oxygens are balanced. But when we put the 2 there, it did affect our mercury as well. So we've got to change that. Right. And so now we've got 2 mercury, 2 oxygen, only 1 mercury on this side, but 2 oxygen. So what we can do, we know we can multiply this by a 2 by putting a 2 up here as a coefficient. So now we have 2 mercury, 2 oxygen, and it is balanced. We are done. We checked it. It's done. Okay. So really, it doesn't take that long to balance most equations if you just follow these simple steps. Right. And that's the end of the lesson.